So today we are going to talk about IoT, and actually I will get to the point. IoT is a big data, and we'll be talking about a few use cases, and at least one, but if we have time, we can cover more. Like Yona said, 2 weeks ago, we actually had one of the, I think maybe the only real big data hackathon for TFL. We have 10 terabytes of data and the surface data, and we have roughly 20 kind of different data sets for a whole weekend hackathon. That was fun. Anyway, so IoT is quite a hot topic. It delivers just like a big data. And there will be, so many billions of devices connected to internet. And how do we drive our business using that? And the gap is actually big data. So again, this is kind of a lot of topics I'm going to cover. Just check who will notify me the time? You?
I'll give you it.
Okay, cool. So, so we will be covering data science maturity model, and which you can gauge yourself or a team or your organization or, the whole region's data science maturity, because there's a huge gap in big data and data science. And also we will spend a lot of time on the data, information, knowledge, wisdom, because it's so important to cover the specific disciplines, techniques we needed. And overall, I'll be focusing on open source, not just the open source software, big data platform, but also open source hardware. I will cover a little bit as well. And equally important, once you have a machine learning model, how to operate it. So how to do microservices using the new technology like Docker. So, yeah. So myself, I've been in my UK career path is pretty much investment banking and energy trading. So, but I do spend a lot of time with the communities. Okay, so this one, I really like this one. So it's from Tom Davenport, Harvard Business Review. It's about Analytics 3.0. It's the era of impact. So if you haven't started the big data, pretty much you are at 1.0, traditional analytics, where it looks like it's quite streamlined. You can do a lot of things. However, there are a lot of data you couldn't handle. And if you have production or you are trialing big data initiative, then probably you are at 2.0, where suddenly you, for any organization, small or big, you suddenly can handle a lot of data sets. However, it's very messy because there's no kind of established enterprise standards, privacy, security, a lot of things. And we really want to go to the next level, where we have near real-time or near real-time rapid business insights out of these data sets. So before we jump into data science, machine learning, and on top of big data, so just cover some basics. People asking me a lot, so what's the difference between BI and data science? The difference is really about, this slide says well, from Aaron's side. Basically, BI can only give you 80% ROI because it covers a lot of what happened and why happened, and probably can handle some kind of real-time what's happening now, but it's very difficult for it to predict what's going to happen next. And the research shows predictive analytics can give you at least a 250% ROI. And if you dig more, it actually says even easily 300%. So that's the difference. We really should be focusing on the big data and the data science, predictive analysis. So I will use example. I was involved for a pharmaceutical new Parkinson's disease drug trial. So first of all, Parkinson's disease, it's a really tough one. There's no cure. And the new drug trial, it requires patients to take the pills 8 times a day. And they want to, if you think about it, how then you can calculate the effectiveness of the drug, basically detecting the tremor frequency and the gait of the patient. It's extremely difficult. However, the technology has been there for years. And every modern phone, since iPhone 3, I think, you have IMU, inertial measurement unit, this gyroscope, accelerometer, and digital complex. And that's extremely cheap. I think it's just a few dollars or even maybe $1. So wearable technology is the way to measure the patient and to detect whether the jerk is improving or actually the symptom deteriorated. So, and that's truly big data because we measured if we only do 10 times per second of measurements, but not just kind of accelerometer, gyroscope, tremoring, but also other biometrics like heartbeat, ECG, EGG, skin resistance, sweatiness, a lot of measurements you can capture on a very cheap, very affordable wristband. That's actually 10 gigabytes a day per patient. And as you probably know, you at least need to have 100, ideally at least 200 patients to make a meaningful jerk trial. So we are really talking about truly big data. And you have to collect at least a few months before the data can make sense. So that's, yeah, easily big data and connected devices. So, and before we jump into the technique or open source platform, just cover the angle of the open source hardware. Arduino has been there for years, and we can see more and more makers. They make the hardware development so simple. Basically, any Java, for example, JavaScript developers, web developers can be a maker because everything the vendors they are promoting is actually open source hardware. You will see open source software logo, but also you will see more and more open source hardware logo over there. That not only these vendors, of course, they want to promote their own hardware and promoting the usage of their chips, but equally important that you can quickly do fast prototype and actually build things, build the products, build hardware. For example, the wearable wristband, that actually we have a team voluntarily doing that, so it's actually quite fun. But anyway, so there are Arduino chip, Arduino-based board, and ARM-based, and also Intel Edison somewhere, yeah. And there's also very famous we call BBB, Black BeagleBone board. So it's all very famous open source hardware, and you can, and also sensors, very cheap sensors, and temperature, humidity, IMU I mentioned, and also, even dust, air quality, all kinds of sensors. So yeah, you can easily prototype things. So not only the enterprise can take advantage of that, startups can leverage this kind of very cheap, and also very big community and ecosystem to build a new product and connect it to the internet. And all of them, the moment that they started collecting data, for example, air quality and all movements, then it's truly big data. So as I mentioned, once you started big data, very quickly or I would suggest you build a data science team at the same time. Not, like most of the banks, they are building data lakes. And then eventually they want to join together, really need to be side by side. And once you have a data science team, like the previous presenter mentioned, you have supervised, unsupervised training, and you can suddenly tackle not only the structured data, semi-structured data, but also more importantly, the unstructured data. And the same disciplines can handle all kinds of use cases in vertical industries. So that's why they are really popular, data scientists and the big data DevOps engineer, because the exact same technique, you can solve so many vertical industry problems. And that's why when you build a team, you should be looking around for truly multidisciplinary backgrounds. So this one is kind of an open source big data science platform. I have a few more simplified slides to cover. But basically, you can take with Hadoop, the difference between Hadoop and the previous kind of a computing platform is really about it does have storage and the compute, especially the local one. Then on top of that, that's a huge ecosystem. And I put Mesos there. I have more slides. So basically, as I mentioned, you can suddenly collect all kinds of unstructured data in real time as well, and very, very cheap storage. And there are, again, established the standard to talk to these data sets. Again, quite the standard. And in the middle, that's the really interesting bit. That's the open source data science toolbox we call. using Python, R, Scala for Spark. And once you have something that machine learning model, you can run on top of Docker, a lightweight kind of a virtual machine. Well, it's not a virtual machine, but basically we just call container. It's so easy to wrap up your ad hoc application and run in a cluster. So, and the involvement here is something called the software-defined data center. And here, again, as long as you open source, you don't need to worry about connectivities. So like Tableau, the previous presentation you saw, you have natural connectivity to not only the big data lake, but also the toolbox. And plus, you have other open source visualization too as well. So I cannot stress how important this slide is. That's the next generation kind of operation side of the big data ecosystem. And in the center is Docker. And on the left is Apache Kafka. That's originated from LinkedIn. So I think yesterday they released the new version, covers more enterprise features. And they do have a company spin-off, Confront, supporting Kafka as an enterprise offering. So the idea is that at the moment, most people are still using Hadoop tool set to ingest data. But you really need to change to messaging-based data ingestion. And the Kafka can take really big load, ingest data into your data lake. But at the same time, you can use analytics to do the real-time decision making. And the Mesos, as I mentioned, it's really important. It's a kind of a resource orchestration kind of a framework. And that's fundamental for a software-defined data center. And again, it's very new, but Twitter has been using it big time, and along with other internet companies. On top of that, and another really important thing is like a toolkit like a Swagger or Mashery. Basically, it's all about API harvesting and the management and the version control. Because if you think about it, there are so many APIs available there, and it doesn't make sense to reinvent the wheel, especially for enterprise customers. IBM, Bluemix, HP on demand, they have a lot of kind of really interesting analytic tools exposed as API. So, and also if you start using Swagger front up as a start, like some other companies I witnessed, like Aliens, they started wrapping up their own API, starting from there. Suddenly you can generate all kinds of client-side library, JavaScript, C#, Java, Scala. Yeah, it's so easy. So you can manage your own internal microservice interface using toolsets like that. And then once you have the APIs, client-side, the server-side, Console is a microservice discovery and management tool, monitoring tool. And the Kubernetes is also important. It's from Google. That's the foundation for OpenShift, Red Hat OpenShift. Basically, it's all about orchestration of Docker containers. And Weave is I think it's a UK, actually UK invested company, open source company, taking care all about networking of Dockers. So yeah, the core OS is from Chromium OS, which is the kind of a Linux image, really lightweight Linux image to run a lot of applications. And this one is also very important, Terraform. And of course, we like AWS, and that's no brainer. You started with AWS. However, you probably will be thinking, what happens if I get locked down by a particular vendor, just one vendor, right? The moment, especially the moment that you start using their high-level services like Redshift. Sorry for the previous presentation. But this one can give you kind of a certain kind of multi-support for the cloud vendor. So yeah, pay attention to this one. So hopefully that can give you kind of a cloud freedom and give you more bargaining power when you invest more and more your infrastructure in the cloud. And this one is kind of a simplified version of my previous open source big data platform. If you go to any internet company meetups like Airbnb, Uber, probably you will be seeing something like similar to this one. So again, on the left side is Kafka. It takes care of all kinds of data ingestion in real-time fashion and also big data. And they push data to the data lake. And on top of that, Hadoop. Then normally you either use Cassandra or HBase to be the distributed key value store, column family based. And in the middle, it's always Spark, Spark, Spark. And also there are emerging technologies coming up. Flink originated from Germany, and it has some extra feature we really like. That's why we also pay attention to it, especially the real-time streaming feature, because Spark streaming is actually macro batch based. So if you really want streaming, kind of a real-time streaming, that's Flink. But overall, going down Spark route won't get wrong, because the ecosystem is so big. I've never seen the growth of this community in my whole career path. And Spark, just let me quickly summarize. So it can do data analytics and replace MapReduce. We don't really do MapReduce anymore. It's always we kick off some job using writing Spark. And you have multiple languages. So not only you can use the native Scala, but also you can use Python and R. So that's PySpark and Spark R. And it can handle streaming use case. For example, Twitter sentiment analysis, or Kafka data ingestion. You can apply machine learning models for your real-time decision-making support. And more importantly, it has graph computing. And the graph computing is so important. I have another slide, I think will cover that. And of course, machine learning library. And the machine learning library, to be honest, there are so many libraries. But for example, Python and R, most of the data scientists will be using that. And the Spark is actually absorbing more and more kind of algorithms, especially those distributed ones on top of their framework. So, and again, here is so important, because not like before, you have to use Eclipse and Visual Studio, for example, to build software. These days, data scientists use more and more notebooks, this interface. That's exactly the interface we deployed for I think more than 100 data scientists over the weekend for them to hack TfL big data. And again, we can support Python, Scala, and R. And the good thing about the notebook interface is not only you have the code, but also the intermediate result. And then you can share with others. So it's a reproducible knowledge sharing tool, as well as a data analytic tool. So, and also the emerging new ones like Apache Zeppelin, similar notebook interface, but specifically for Spark. And there's a Zeppelin for R, so you can use Spark R. So all in all, that's the trend. So that's kind of, the best kind of combination we can recommend for any organization, purely open source based. So how much time do I have? Just quickly check.
6 minutes.
Okay. So I will spend a bit more time here. That's a bit busy. But it's sometimes, people say, that's too much. So how can I get started? So I better start with data, information, knowledge, wisdom, or intelligence. So a lot of big data company will show up and say, hey, we can help you converting from data to information to knowledge to wisdom. And now I'm going to drill down to see at each stage what kind of a basic capabilities you need to have. The basic ones, red ones, eventually get to the advanced ones. So that's the idea. So for example, data, of course, you can, most of the organizations for relational database, that's pretty good. And the rest for API, maybe still some SOAP or web service. But anyway, so rest for JSON is the way going forward. But very quickly, and even here, API harvesting is actually, I think it's intermediate. It's not even advanced one, but most of the organizations don't have API strategy or policies. But very quickly, unstructured data, images, videos, and for example, for compliance use cases, most of the solutions kind of will be struggling. And then from data to information, again, the first one, I think it's basic, is actually natural language processing. reality is that, yeah, it's actually quite difficult for a lot of organizations to process unstructured data. So, and I put some stars here. Basically, that's the really important thing any enterprise customers need to be paying attention to. Unstructured data, natural language processing, ontology, and graph management. This is really important because so far, most of the MDM is really about relational database hierarchy structure. But ontology, basically just like Facebook graph search or Google knowledge graph, it's really modeling the words using graph, basically some nodes and relationships. For example, compliance use case. So not only we want to know this particular trader is in front office, but also we want to know the historical his job titles, maybe in the back office. Then you need to pay attention. So not only you need to model your word in a kind of a multi-dimensional way, but also with a timeline as well. So that's ontology and the graph management. And the streaming processing and time series analysis, because so many use cases can be covered by time series data, and especially the bigger ones. We're talking about easily billions or trillions of data. And then there's somewhere, I think should be neural network, that's deep learning thing. So again, sometimes, yeah, I mean, as far as I can see, any industry can be disrupted. So yeah, just be careful. And the deep learning is so important. Google and other big internet companies are investing a lot. However, I think it's again like the open source ecosystem. We have more and more tools can help our enterprise users to apply deep learning technique, especially for time series, using, for example, recurrent neural network. Anyway, so I was only 2 minutes. Okay, so to summarize, IoT is really, the moment you start collecting data, we are talking about the multi-dimensional time series, geolocation, and all kinds of other unstructured data, for example, social networking. So to review what you are at, maybe just do a quick kind of a comparison of a classic data architecture to the modern big data architecture. From full text search to natural language processing, from the video audio to computer vision and deep learning. And from relational database data warehouse to distributed key value store graph database, as well as a big data warehouse. And from business intelligence to data science machine learning, from N-tier architecture to lightweight container and microservice and API harvesting. And of course, it's overwhelming. This is just for Hadoop alone, so you have to learn so many things. But the reality is that, there are so many open, free resources on the internet. And I think the slides can be distributed, so you can have a look. That's our recommendation. And also, you can buy some books. Again, data science for business, for example. And if you are, data science, doing data science, and also Python for data analysis, if you have a lot of Python guys. And of course, MOOC, Massive Online Course, that's definitely the good start. As well as the Docker containers and also virtual machines. You can just download the big data virtual machines from these vendors onto your laptop to learn, to test the ideas. And also, we will be recommending personally the data science certification through EMC or Cloudera. And there are a few out there, but these two are pretty good. So if you want to add the new job career or job kind of a career path for your employees. And definitely hackathons. Keep calm and hack. So it's very effective. So if you are a big organization, do organize hackathons, you always, within 48 hours, you will have unexpected, interesting outcomes. And if you are interested, just go to hackathons. Again, you can learn an awful lot. And they are extremely friendly, and meetups as well, free beer, free pizza. So, and I learned a lot from these events. So that's really it. So any questions?
And then?
So IoT, you can see it's the problem. It's really big data, and it's overwhelming, but it's really fun. It delivers, and any questions? please do ask. And we organize a lot of meetups.
Two
so
questions, one over there. We have two over here. Hold on, somebody.
By the way, this Monday, right? This Twitter at the meetup, Big Data meetup is actually Twitter. It's a really interesting one, really advanced stuff.
So, as you said, it's effectively overwhelming. How do you organize yourself, and which resources do you, I guess, read to be on top of these so many technologies and paradigms and big words and stuff?
So the question is, yeah, it's overwhelming. How do you put together all this technology? But well, that's misleading. So when I talk about all this technology, you really need to start with the business. You know, you put the different.
Sorry, the question is,
yeah.
How do you get on top, or how are you informed of, and how are you on top, and how are you informed of all these things happening, all these new technologies coming and appearing? You know. Like to be informed to make decisions,
yeah.
To apply to your, right? Because, so for example, I try to be on top of as many as I can and are not near close all the things you expose here.
Yeah, that's a really good one because, yeah, it's difficult for any individual or organization to understand what's the next one is the best fit for myself. So first of all, from the enterprise level, I would be suggesting we lower the PSL criteria to encourage establish the startup, for example, 5 to 6 years old kind of a big data startup to test it with your problems and your data, to give them the chance. Because otherwise, these guys, they don't have enough financial kind of a record history, so you cannot be on the PSL, then the enterprise will never be enjoying any benefit of the new kind of emerging technology. And that's for the startup side. And for the technology side, again, from the enterprise level, I would be suggesting, going to the hot hubs like Silicon Valley, do some kind of a proper research and with the problems, with the business problems, with your data profile, data architecture profile, to ask questions from different like, for example, Spark Databricks, which is UC Berkeley based. So do talk to them. And they've been dealing with all kinds of customers, bigger ones, telecom, pharmaceutical. They might actually give you some directions. Right? And also individual level, attending meetup, really sit down, finishing some massive online course. That's, But more important is actually sharing the experience. And as I said, I learned a lot from the communities. That's why whenever possible, we contribute back. For example, we build, we combine the best open source this tool into a Docker container for data scientists to crack a problem. And also we will be introducing more like open courses of our own for people to learn and to test. So yeah, it's a difficult one. So a lot of time.
Sorry, now that you know Charles, you can just ask him. Right. I think we have a second question. Kier?
This quick one is very related. I think one of the challenges we face with all the things that keep changing in the industry is to keep our data architecture simple. So do you have any tips on how to keep our data architecture simple? Because all this, I mean, Spark, we're moving to Flink, all these things are changing all the time. And there is a cost to change. There is a cost to bring everyone in the team up to speed with these technologies. There's cost to change infrastructure. There's cost to install things. There's cost to everything, right? So how do you actually build something which is simple so that you can deliver new business benefits at pace?
Exactly. So you cannot really play with technology. Just so many of them. Every day, not every week or every month. Every day I see new things coming out. So you basically like creating a kind of a source code branches, right? You have the main branch, which is seldom changed. Let's say every quarter you do a big upgrade. Then you have a smaller data cluster, data lake. You can test the ideas. For example, back to the simple question. So a simple architecture. Normally previously we use Avro format, columnar-based, but now we use Parquet pretty much for every structured and semi-structured data sets. And either on top of S3, which is in AWS, or in HDFS, Hadoop. Then you can use Spark or any other language, because Parquet itself, like Avro, it's it has self-describing schemas. So Parquet per Spark, and with Python and R library enabled, then you can cover majority of the use cases for at least a year. Beyond that, I couldn't tell. Yeah.
Okay, we do have to
keep it simple, indeed.
kind of get on with it because we're almost